February 4th, 1975, Haicheng, China, a city of over 1 million people. For weeks, something strange had been happening across the region. Snakes came out of hibernation in the dead of winter and froze to death in the open, which snakes do not do. Snakes do not make mistakes about when it's safe to leave the ground. Rats appeared in broad daylight, disoriented, running in the open instead of staying hidden, which rats also do not do. Farm animals refused to enter their barns. Dogs barked at nothing, for hours, at walls, at empty air. Chickens stopped laying eggs entirely. And in the days right before, witnesses across the region reported something even stranger. Birds went quiet. Not occasionally quiet, completely quiet. No birdsong, no movement in the trees, as if every bird in the region had been switched off at the same moment. Officials, watching this pattern build for weeks, made a decision that would later be called one of the most successful predictions in the history of seismology. They ordered an evacuation. On February 4th, just hours before a magnitude 7.3 earthquake leveled the city, over 1 million people were already outside, away from buildings. Estimates suggest the evacuation saved over 150,000 lives. The animals knew. Hours, in some cases weeks, before human instruments detected anything at all. The question of how is one of the strangest unsolved problems in modern science, and the answer is closer than you think and far stranger than you'd guess. Haicheng is the most famous case. It is nowhere close to the only one. In 2004, in the hours before the Indian Ocean tsunami killed over 230,000 people, wildlife officials in Sri Lanka's Yala National Park documented something that became one of the most discussed details of the entire disaster. Elephants in the park moved to higher ground hours before the wave hit. Flamingos abandoned their usual low-lying breeding areas. Dogs at a beach resort reportedly refused to go near the water that morning, something staff had never seen before. When the wave finally struck, the human death toll in that region was catastrophic. The animal death toll across the entire park was reported as nearly zero. In 2009, before the Aquila earthquake in Italy, researchers studying a population of toads at a breeding pond documented something extraordinary almost by accident. They had been tracking the toads daily as part of an unrelated mating study. 5 days before the magnitude 6.3 quake, the toads abruptly abandoned the breeding pond entirely. Numbers dropped from roughly 96 toads observed daily to nearly zero. They didn't return until after the aftershocks had fully stopped. This pattern has now been documented in some form across over 130 recorded earthquake events going back more than 2,000 years. Ancient Greek writers recorded it. Roman naturalists recorded it. It is not folklore that survived because people wanted to believe something magical. It is a pattern that kept showing up, in writing, across cultures that had no contact with each other, describing the same thing in the same sequence. So the question stopped being whether this happens. It happens. The question scientists have spent decades chasing is how. For a long time, this question sat outside mainstream seismology, mostly because there was no mechanism that made sense. Earthquakes happen deep underground, sometimes kilometers down. The idea that an animal on the surface could detect something before the ground actually started shaking sounded to most geologists like folklore dressed up as science. Then, researchers started looking more carefully at what actually happens in the rock itself before a major fault ruptures. The leading theory involves something called the lithosphere-atmosphere-ionosphere coupling model, and the mechanism behind it is genuinely strange. In the days and hours before a major fault slips, The immense pressure building in the rock can cause peroxybonds, a kind of defect in certain mineral structures, to break. This releases positively charged particles that travel upward through solid rock, all the way to the surface, where they ionize the surrounding air. That ionization changes the local electromagnetic environment in measurable ways. It can alter air chemistry. It produces low-frequency electromagnetic signals undetectable by humans, but well within the sensitivity range of animal nervous systems built for exactly this kind of input. This matters because so many of the animals reporting this behavior, snakes, toads, certain birds, certain fish, have biological systems specifically tuned to detect electromagnetic and chemical changes in their environment as part of normal survival behavior. A snake's tongue reads chemical particles in the air at a sensitivity that dwarfs human smell. Many fish species have electroreceptive organs built to detect electrical fields in water, evolved originally to find prey, not earthquakes. Birds have magnetite-based structures in their beaks, the same mechanism that lets them navigate using Earth's magnetic field, which makes them sensitive to exactly the kind of localized electromagnetic disturbance that pre-earthquake stress might generate. These animals are not predicting earthquakes the way a seismologist predicts earthquakes. They are detecting something physical, present, and real, hours or days before it produces a shockwave humans can feel. Their nervous systems were built, by complete evolutionary coincidence, to notice it. Here's where this gets genuinely strange, and where current research has run into its most interesting wall. If the ionization theory were the complete answer, you'd expect every sensitive species in a region to react roughly the same way, at roughly the same time. That's not what the data shows. A 2020 study tracking animal behavior at a wildlife reserve in Germany using GPS-tagged cattle, dogs, and sheep found something the researchers didn't expect. The animals didn't all become agitated at the same moment before seismic events. Different species responded at different times, in a layered sequence, almost like a relay. Some species responded days out, others reacted only in the final hours. The closer an earthquake's epicenter was to the animals, the earlier in the sequence their behavior changed, which suggests something more specific than a single universal signal. It suggests animals may be detecting a cascade of different precursor signals, not one. Chemical changes, electromagnetic shifts, possibly subtle ground tilting imperceptible to humans but detectable by animals whose entire bodies are in constant contact with the Earth, possibly infrasound, extremely low-frequency sound waves below the range of human hearing that travel through rock ahead of a rupture, and that elephants, famously sensitive to infrasound through their feet, would detect long before any instrument humans had access to in 2004. Which means the full picture may not be one mechanism. It may be dozens of overlapping biological sensors refined separately over millions of years of evolution for completely unrelated reasons, that happen, by sheer coincidence, to collectively form one of the most sensitive early warning networks ever observed. No engineer designed it. No species developed it for this purpose. It assembled itself, accidentally, out of survival traits meant for entirely different threats. Researchers in China, Japan, and Italy are now running active monitoring networks specifically tracking animal behavior alongside seismic instruments, treating the animals themselves as sensors, not metaphorically, literally. Biological seismographs that were online and functioning millions of years before the first instrument was built. So, back to Haicheng, a city saved not by satellites, not by sensors, not by any piece of technology humans had built. Saved because enough officials were willing to take seriously what the snakes, the rats, and the silence in the trees were already telling them. We are, still, even now, only partially able to explain what those animals were detecting. We have theories, we have mechanisms, we have decades of recorded cases stretching back to ancient Rome. What we don't have, not yet, is the full picture. But here's what we do know. Somewhere, right now, in some part of the world, an animal's nervous system, built for a completely different purpose, may be quietly registering something the most sophisticated instruments on the planet haven't picked up yet. The silence in the trees was never empty. It was the loudest warning available. We just hadn't learned, yet, how to listen.